Hello everyone, welcome back to Edumoon tutorials. In this particular video, we will be covering how to deal with the different binary codes. Myself Sohana of Andhra University, and let's get started. At first, we will be covering gray code. Now, how to find a gray code for a given decimal digit. At first, we will be considering the binary values as given. The only thing we should consider while converting binary to gray code is that we will be using with the help of XOR gates. I hope you are aware of XOR conversions. For example, A and B stands for these values. Now, if A and B both are equals to 0, then your output will be a 0. If A is 0 and B is 1, then your output will be 1. If it is 1 and a 0, it will be a 1. If it's 1 and a 1, then it will be a 0. It's basically a odd 1 detector, okay? Now how do we convert? Coming to the conversion part, at first we have 0, 0, 0, 0 for the decimal 0. Now, in order to convert in the gray code, first write the first digit in your binary. Always this 0 is dropped down here as it is. Like whatever the values will be at the starting, that is dropped down to the gray code. And then what we will be considering is that we need to take the XOR for these two. 0 and 0 XOR is 0. Now again 0 and 0 XOR is 0. Now again 0 and 0 XOR is 0. That's it. Your gray code is obtained. The same goes with all of them. Now again consider the first bit of 0 to be placed directly, and then XOR of 0 and 0 is a 0, XOR of 0 and a 0 is a 0, XOR of 0 and a 1 is, according to our rules, it is 1, so drop them a 1. Now again 0, 0, 0 and 1, 0, XOR of 0 and 1 is a 1, XOR of 1 and 0 is a 1 again. The same goes with all of them. So in a similar fashion, we will be writing all those values as follows. Okay, now how to convert gray code into binary code? We have seen here from binary to gray code. Now we will be looking at gray code to binary code. Now consider the string of zeros and ones as given here. Now usually what we will be doing here is first drop down the first value, like whatever value is present in this one, just drop down as it is. And now we will be doing cross XOR conversions. Like this one and 0, we will be having an XOR. 1 and 0 is a 1. Now again 1 and 1 XOR is a 0. 0 and 1 XOR is a 1. 1 and 0 XOR is a 1. 1 and 1 XOR is a 0. 0 and XOR of 0 is a 0 again. 0 XOR 0 is a 0. 0 XOR 1 is a 1. 1 XOR 0 is a 1. 1 XOR 1 is a 0. Now, I hope you guys understood this very clearly. For gray to binary, we will be doing cross XOR. For binary to gray, just normal XOR. Okay, XOR or XOR are also the same. Don't get confused for this one. Now, let's verify doing binary to gray. Again, this one, same, it gets a drop down. Now, 1, 1. This is the normal XOR and this is the cross XOR. Okay, 1 XOR 1 is a 0. 1 XOR 0 is a 1. 0 XOR 1 is 1. 1 XOR 1 is 0. 1 XOR 0 is 1. 0 XOR 0 is 0. 0 XOR 0 is 0. 0 XOR 1 is a 1. 1 XOR 1 is a 0. 1 XOR 0 is a 1. See, this one and this one both are the same. 1 0, 1 1, 0 1, 0 1, 0 0 0 0, 1 0 1 0 and 1. So, till here we are done with our gray code. So, now let's look on to excess 3. As the name suggests itself, like excess of 3 means adding 3 to whatever decimal value we have. So, 0 plus 3 is equals to 3, right? So, what's the binary code for 3? Let's use 4 bits. So, it will be 0 0 1 1. So, the excess 3 code for the given decimal value 0 is 0 0 1 1. Similarly, 1 plus 3 equals to 4, right? So, what will be the binary code for this one? 0 1 0 0. Like if you just consider 8421 to be like this. Fine. Now again 2 plus 3 equals to 5. So, the binary code for this one will be 0 1 0 1. Similarly, we will be writing for all of them. So in this way we filled all these values. So for any given decimal value, you just add 3 to that and then find its binary code. Okay, now let's look into 8421. Usually while solving any other problems also, for easier conversions like from a decimal to the binary, we will be writing like 8421 and then assigning its weights, right? Here 8421 basically means that It is a weight, actually, just a weight, that's it. For 0, 0, 0, for 0, it will be 0, 0, 0 and 0, right? Because we have nothing to represent it with it. Now for 1, if you just assign a 1 bit to this one, you will be getting the value as 1. So and similarly for 2, if you just assign 1 bit in place of 2, you will be getting this one. Similarly for 3, 2 plus 1 is 3, right? So according to those weights, 8 and 4 be 0 and 2 and 1 stands for 1, 1. So this value 2 plus 1 will be a 3. Now 4. Only 4 we need to turn it to the 1. So 1 and 0, 0. Now for 5, how do we represent 5? 4 plus 1 is 5, right? So 8 goes with 0, 4 goes with 1, 2 goes with 0 and 1 goes with 1 again. Now 6. 6 means 4 plus 2 equals to 6. So 0, 1, 1 and 0. 7 is 4 plus 2 plus 1 according to the weights values. So 0, 1, 1, 1. Now 8 is for 1 and 0 and 0 and 0. Now 9. 9 means 8 plus 1. So only we are assigning 1 to 8 and 1. 4 into turns to be 0. So till here we are done with 8 for 2 1. Now let's look into the other different kinds of binary codes. Now let's look on to 2 for 2 1. Well, 2 can be represented as, according to these weights, we can either use 1, 0, 0 and 0 because this one stands for this 2, or else we can turn this 2's value like 0, 0, 1 and 0. Similarly for 4, we can just turn on this 4 value like 0, 1 and 0, 0, or else these 2's can be turned on like 1, 0 and 1, 0. But out of these two values, which one is true? And for 4, out of these two values, which one is true? So here what we will be considering is that 2 for 2 1 acts like a self-complementing code. What did I say you? That it's a self-complementing code. Like, what are the self-complementing ones? 0 and 9 are self-complementing. 1 and 8 are self-complementing. 2 and 7 are self-complementing. 3 and 6 are self-complementing. 4 and 5 are self-complementing. Now, in order to write 0, we will be using 0, 0, 0, 0, right? Now, how can we write 9 according to this? Just complement all these digits. Like it's 1, 1, 1 and 1. So, if you assign weights to these one, 2, 4, 2, 1, 2 plus 4 plus 2 plus 1 also equals to 9. Hence, 0 and 9 can become as self-complementing ones. Now, consider 1 and 8. How can we be writing 1 here? 0, 0, 0 and a 1. Now, just complement these values. It will be like 1, 1, 1 and 0. So, the value 2 plus 4 plus 2 equals to 8. It's done. Now 2. Just consider the lower bits only initially. Don't go with the higher bits. So, when we consider lower bits, we can write this as 0, 0, 1 and 0. Now, how can we complement this? 1, 1, 0 and 1. So, now we see the value as 2 plus 4 plus 1 equals to 7. Similarly, the 3, 0, 0, 1 and 1. Self-complementing the 6, 1, 1 and 0 and 0. Now 4, how do we write 4? 0, 1, 0 and 0. 5 can be thus written as 1, 0, 1 and 1. So, you can see all these codes, like this is complementing this one, this is complementing this one goes with this one, and similarly all of them. So, now we are done with the 2 for 2 1. Now let's see another kind of binary code. So now let's see the last kind of binary code, which is 8, 4, minus 2, minus 1. Here all of these represents weights. Now, how can we represent 0? Similarly, 0, 0, 0, 0. It's always the same for any kind of binary code system we use. Now 1. How can we write 1 here? See, 4 minus 2 is plus 2. And 2 minus 1 is 1. So what should we do now? We need to turn this bit and this bit, and we should leave this to be 0. So how do we write that? 0, 1, 1 and 1. So while turning these 3 bits on, only the values of 4, minus 2 and minus 1 will thus produce a value equivalent to 1. I hope you are very clear. Now see 2. For 2, how can we get the value of 2? 4 minus 2 is 2. Right? So only we need to turn on these 2 bits and just let these bits be staying idle. So 0, 1, 1 and a 0. Now for 3, how do we get 3 now? 3 can be written as 4 minus 1, right? So 0, 1, 0 and 1. Now how do we write 4? It's simpler, just a 4. So 0, 1 and 0 and 0. Now 5, how do we get a 5? 8 minus 3 equals to 5, right? So 8 bits is turned, 4 just 0 and minus 2, 1 and 1. So 8 minus 2 minus 1 equals to 5. Now 6, how do we get 6? It's 8 minus 2, right? 8 minus 2 is 6. So 1, 0, 1 and a 0. Now how do we get 7? 8 minus 1 is 7. So 1, 0, 0 and 1. So 8 is again 0. Sorry, 1, 0, 0 and 0. Now, how do we get the value of a 9? See, 8 plus 4 is 12. 12 minus 2 is 10. 10 minus 1 is 9. So we need to turn on all the digits. So it's 1, 1, 1 and 1. Fine. Till here we are done with our binary codes. I hope you like this session. For more videos, stay tuned to Edumoon. Thank you.